In this exercise, we're going to be finding the overlapping segments. So we've got overlapping sectors, and we've got one. So I'll just draw this out a bit. So we've got the first one, the one on the top here, which looks roughly like this, and this is a sector, and it's very poorly drawn, but the sector looks something like this. It's 10 meters, and that's going to be the radius, and the sector has got a certain area, which is this here. So we're going to find the area of the sector, and then we're going to partition it like this. And we're going to find the area of the triangle, which sits on top. Then we're going to subtract the area of the triangle from the area of the whole sector to reveal just the segment on the bottom. So that's our three-part strategy. So step one, we're going to find the area of the sector. Part two, we're going to find the area of the triangle. Third, we're going to take the area of the sector and we're going to subtract the area of the triangle, and that's going to equal the area of the segment. That's what we're going to do. So that's what we're doing first. Now, when we've done that to both of these, when we've done that to both of them, we're going to add the two segments together to find the total area of both. So we're going to start by just doing the top bit, and the top bit really is this one here. So if I was to draw a line roughly down the center there, we're going to find this bit here. That's what we're trying to find. Sorry, you can't see it particularly well. Maybe if I did that in a different color, maybe red perhaps. Red's not very good either. What about blue? Sorry, this pen looks green, but is it going to be blue? Or it's black. Okay, that's not very helpful. I want blue. Is this blue? Who knows? We won't worry about it. But nonetheless, this is the bit we're trying to find. This bit in here. That's our target area we're trying to find. So let's go ahead and follow the strategy here, and we're going to do that for both. So we're going to. This is the upper sector, and we're going to do the lower sector, and then we're going to add the two parts together, the two segments together. Those two things there. There's one. We're going to add the other one to it. So let's have a go at doing the upper one first. So the first thing we're going to do is find the area of that upper sector. So here it is. I'll just draw it nice and small again. Here it is. And I'm just going to write and populate this with the information that we need. So here it is. This is 10. Of course, this is also 10. These are in meters. We've got the angle at the top here. This is 100 degrees. And let's go ahead. So first of all, let's go area of sector is equal to theta on 360 times pi r squared. So that is our formula for finding the whole sector, the whole thing. So let's have a look, and that's just all of this together, yeah? So if I was going to shade this in, that's what we're finding. So theta in this case is 100 over, we've got 360, and we're going to multiply it by pi r squared. Well, pi is pi, but r, these are the radii. There's one radius there, another radius there, two radii, so it's going to be times 10 squared. Okay, so let's have a look, see how that all plays out. So we've got 100, in fact I'll just do it so I can see it. This calculator is very dirty, I need to clean it. So 100 over 360 times pi times 10 squared. I'm just going to write in 100. There it is. And I get 87 point, and I'm going to call that 87.26. No, 87.27. I'm going to round as I go. Not great mathematical practice, but the purpose of this is just to show the strategy for revealing the area of the segment. So I'm just going to go ahead and call that 87.27. Here it is. The area is 87.27. In this case, it's going to be square meters. It's to 2dp. There it is. All right, let's do the next bit. So that was the area of the sector. Now let's find the area of the triangle. So the area of the triangle is going to be this bit here. All right, here we go. So the area of triangle, I'm going to call it area of triangle, is going to equal, now the area of the triangle, we're going to use the triangle sine area rule, which is half BC sine A. Now B and C are going to be the angle arms. So it's these two here, which is 10 and 10. So it's going to be 1/2 times 10 times 10 times sine A. So well, A is going to be the angle at the vertex here. Now, by the way, the sine area rule really only works when you've got a known angle in between two known sides. So that's what we're using there. So this is going to be, so 1/2, 10 times 10 times, oops, I didn't write that in, 100. There it is. I'm getting ahead of myself. All right, so let's calculate that now. So 1/2, or 0.5 I'll call it, times 10 times 10, I'll put 100 times the sine of 100, because that's the angle at the vertex, is 49.24. Excuse me. 49.24, and that's going to be in square meters. And that's also 2dp. So now what we're going to do is we're going to go ahead and we're going to take these two and we're going to subtract the triangle from the sector. So we're going to say, so we're now after this bit here, we're after this bit in here. That's the third stage. So we're now going to go area of the sector is, area of the segment, that's a G, segment is equal to the area of the sector minus the area of the triangle, which is equal to the area of the sector is 87.27, the area of the triangle is 49.24, 49.24, and the total thing comes to, let's have a look. So I'm going to go 87. So I've got 87.27 minus 49.24. Where do we get to? And I got 38.03. So I got 38.03, and that's going to be square meters, and again to 2dp. All right, so that is the first half done. So we now know the area of this bit here. I'll put a little arrow here. That bit there, the bit that I tried to colour in very poorly, is 38.03 square meters. All right, now in this next video, I'm going to find the area of the upper bit, which in this case is the lower sector, but is going to be that upper portion there of the segment. And we're going to do that in the next video.